Hello everyone, I'm Alfian and today we are going to solve the LeetCode challenge or the challenge number 122 called the best time to buy and sell stock 2 or the version 2. And we are given an integer array of prices where the prices of the current index of the certain element is the price of a given stock on the certain day. On each day, we may decide to buy and or sell the stock. We can only hold at most one share of the stock at any time. However, we can sell and buy the stock multiple times on the same day, ensuring that we never hold more than one share of a stock and find and return the maximum profit that we can achieve. And for this challenge right here, we have the function of the called the max profit, which in a form of TypeScript. If you want to use something else other than TypeScript language, then go ahead. I encourage you to do so. And we have one parameter which is prices array in the form of number array, since it is denoted in type of the TypeScript language, and the expected output is in a form of number or integer. So we need to return an integer instead of returning any data type other than integer. Okay, so for the example one right here, let me explain for a moment that we have 7, 1, 5, 3, 6, and 4. And the output is 7. Why? Is because we buy on the day 2, which is 1 right here, which the current lowest price possible on the day 2, rather than day 1, which is 7, which is expensive. And we bought the stock on the day 1, and then we sell the stock on the day 3, which is on the next day, and we have the difference between 5 and 1, which we can calculate by subtracting it with 5 and 1. 5 subtracted by 1 and it's equals to 4, and it is 5 and 3. Then we don't have any answer of the 5 and 3 because 3 is lower than 5. It would have been a negative or not a profit for this particular challenge. And for this part of the array, we have 3 and 6, which is possible to be sell the stock with the profit of 3. So we have 4, and then we have 3, then we got 7, and then finally 6 with 4, since we don't buy 6 because 4 is already down the price. 4 is lower than 6, then 4 is not being considered to be sell because it is not a profit. So we buy day 2 and we have the profit of 4, and then we buy on the day 3 and sell it on the day 4, so we got profit of 3. Then in total we got 7 as our total profit or the max profit function. And as we know that we need to declare a profit using the let profit of the current profit, which is 0, and then we need to return the profit itself, return the variable as the result of the profit. We have the starting value of the 0 is because on the example 3 right here we have 7, 6. Of course we don't want to buy 7 and sell it on the day 2, which is 6. It's not a profit. And also 6 with 4, we don't want to sell it because it is also not a profit, then it is also going downhill from the day 1. So we don't have any possible day or any comfortable day to sell our stock, then we are returning 0 as our answer instead. And for the initial value of the profit variable right here, which is stated as 0, then we can just return the profit right away, just in case if the stock on the whole days already going downhill from the day 1. So since we already know that on each day we can buy and sell at the same time, but we don't hold one stock on each day, then we can just be flexible and trade all of the stocks to see which one has the maximum profit possible. So without further ado, let's solve this out. We are using the sliding window technique because of on the each day right here in the statement, we may decide to buy on N or sell the stock, and we can only hold at most one share of the stock at any time. So And the other statement says we can sell and buy the stock multiple times on the same day, ensuring that we never hold more than one share of the stock. So that is why the sliding window technique is shining here. It's because on the escalator drawing right here, let's go to the escalator drawing, and we have the array of 7, 1, 5, 3, 6, and 4, just as stated on the example 1 right here. And we use the sliding window technique like this one, and we are highlighting on each array iteration. On the usual array iteration of the for loop, we are starting from the index 0, which is reading the 7 and then 1 and then 5, 3, 6, and finally 4, and then the for loop will stop because 4 is already on the edge of the array, so we don't have to read anymore to prevent the index out of bound after reading 4. So the while loop will stop. But for this case, we are modifying the while loop statement to use a sliding window technique. So the sliding window will highlight two numbers at a time, and then as the for loop traverses over the prices array, then it will be like this: 1 with 5, 5 with 3, 3 with 6, and finally 6 with 4. And for the modified for loop, we are iterating from the using the for let I is equals to 0 as long as I is below the prices dot length. Since prices dot length is 6, we have 6 element right here: 7, 1, 5, 3, 6, and 4. And then we are stating that the I is lower than the prices dot length, so the I will read onto the back of the array like this, I with 7. But then since it is highlighting two numbers at a time from the traversal technique, then we don't want this to be indexed out of bound, so we need to use prices.length and then -1. So that way we are shifting the prices length -1, but then we still can read the next window of the highlighted index. So let's say we are highlighting the index 6, since array or the for loop traversal will always starting from 0 from the statement right here, let I equals to the 0. Then we are highlighting on the 7 right here. As we go through the array traversal on the prices length -1, then it will prevent the sliding window to get out of bound. So we can just place on the end of the traverse array or the end of the for loop like this, and then finally we can use the semicolon and then I++. And that way, after we iterate this one, we can check if 7 and 1 is considered a profit or not. If it is not, then we skip this only to check if the numbers highlighted are profit. 1 with 5 right here, since the current index of the I is lower than the I plus 1, which is 5 right here, which is stated on the second iteration, and 5 is higher than 1, then 5 will be subtracted by 1 and we got the temporary profit of 4. Then we can accumulate the temporary profit into our sum of the profits. So that way we can return the integer as the answer of this challenge. And then we need to traverse over the 5 with 6 on the third iteration. Since 5 and 3 is not considered a profit, since 5 is higher than 3, since the former is higher than the latter, so it will not be processed about, and we can just skip it to the next one. We have the 3 and 6. Since 3 and 6 has the difference of 3, then we need to sum the temporary profit as 3, and then we accumulate with the previous profit, which is 4, and we got the value of 7. Then finally we are iterating over the 6 and 4. Since the former is higher than the latter, then it is not considered a profit, then we can just skip this part. And let's say if we have the value of the stock prices are going downhill, like 5, 7, 6, 3, and then 2, 1, and finally 1. And we can just traverse over the 7 and 6. Since we don't have any profit right here, we can skip this, and this part we can skip this part also, and this part skip this skip this, and finally also skipping this part, because the 1 and 1 right here, which has the profit of 0, since we already initialize the current profit as 0 to be returned back from the function, then we can just use that without modifying anything to reduce the processing power. So let's go back to our code, to our implementation. We can just use the sliding window technique. Using the for loop, let I, as already stated earlier, I is equals to 0 as long as I is below the prices dot length, and then -1. Don't forget to add the padding as the -1 because we are working with the sliding window. Then I plus plus. And inside the for loop iteration, we can just check with the sum if the prices of the current iteration is lower than the prices of the I plus 1, which is on the next window, which is on the later part. So we can just sum the profit using the plus equals sign or the operator, and we can just subtract in the prices of the I plus 1 subtracted by the current prices of the current index. And as simple as that, we can just run the code to see if it works. And we have the accepted solution. Let's submit this to ensure if this works. Okay, so that's about it. I hope you understand my explanation. If you still don't understand, you can ask me in the comment section, or if you have any better solutions regarding this challenge, tell us what you think in the comment section. Thank you for watching the video. I hope you have a great day, and I will see you in the next video. Goodbye.